Great. Nicole, do you want to validate that you can actually hear little bouncy bars in OBS? By hear, I mean see little bouncy bars. Bouncy bars are good. It'll take a minute for it to come through on YouTube. Does it sound good? I don't sound horrible? I mean, worse than normal? Cool. Okay, I'll turn this off till we're ready to go. Jenny! At least one friendly face. She came without the tomatoes and eggs to throw, which is even better. As far as I know, that's a good point. I don't know, that sometimes makes it worse, depending on how good their arm is. Yeah, definitely cuts down on the miss. Nicole, am I allowed to start? Should I wait a few minutes? I can talk to myself. I'm good at it. Shortly after 6. But are they watching intently? I mean, I could boost viewer numbers. Do you want me to make it bigger? I mean, I can just add one more viewer real quick. I mean, 33% increase is a pretty... But my timer was until 6. That's true. It's because it started counting up once it hit 0, which was weird. It's true. That's fair. If it that, assuming we get that high. Yeah, I had some what? I didn't do nothing. Yes. Welcome. Shortly. Way off in the background. I will warn you, you can't completely trust those statistics. When I'm on the stream, I see my numbers bounce all over the place, and people will show up and disappear. It gets worse if people start alt-tabbing around windows or changing tabs. Loses tracking, can't count. Counting's hard. We're programmers. We don't do the counting thing very well. Increment and decrement. No one's ever missed by 1, ever. At least not the people here. Other people do. Oh.
Right next to each other. One would be like $1 million mansion, the other would be a mobile home.
Slightly different tax amounts, I imagine. Huh?
Yeah.
Assessment cards. Okay. It was like, wait, my place is worth how much? For that price, I will sell. It's like I will sell if somebody wants to pay me $6 million for my place. I will. I don't want. But for that price, I think I would. Yeah. Yes, I would happily do it for that price. Maybe not completely happily. But I would be mildly tolerable. Although at that price, you just hire. Problem solved. Yeah. It's like, who here has a free... I'm buying. Nicole told me I could start at 6:05, and I'm counting the seconds on my phone. You said 6:05 on the dot, right? So as soon as I see this thing roll over to 0, I can start? Yes. Cool. Okay, we'll get going then. Welcome, everybody. Hopefully by now you figured out where you are. This is the Spokane.net user group with discussing MSBuild beyond building. I am Kevin, in case you haven't figured that out. If you are in the wrong place, this is the time to leave. Snacks and everything in the kitchen. I don't mind if people get up, walk away, whatever, feel free. I think most people probably know this, but here at IntelliTech, we sponsor different user groups in the area. There's a .NET user group, a DevOps user group, and a Spokane Python user group. That was hard to say. Yeah, so sponsored by IntelliTech. We're just going to skip right on over that. So this is going to be a reoccurring theme with all of these. All of the user group meetups are now done for April. The next ones are all in May. And all of them are conveniently giving the exact same talk next month. Come on in. Feel free. Grab a seat. Every single meetup next month is hosting TBD. And so we will figure out what those talks are. So for people who are not subscribed, watch the meetup pages. Head on through. There will be lots. So again, Python, or I should say .NET May 10th, Python May 17th, and DevOps May 24th. All topics TBD. And if anybody has a topic they would like to either hear or speak, please let us know. IntelliTech, if you want to get updates on meetups, various things that are going on with us, Facebook, Twitter, and YouTube, we would really, really, really love if about 5 more people would subscribe on YouTube so we can get to that coveted 100 and actually reserve our name on there, which would be cool. So if 5 of you would like to go and click that button, this is the only time I'm going to shill for it. Now and last Thursday. Okay, tonight, me. So, going on MSBuild. I'm guessing most people here, whether you've realized it or not, have actually gone through and spent a bunch of time working with MSBuild. It's the underlying system that compiles all your stuff, runs your CS proj, this, that, and the other. For a brief history lesson, way back in ye olden days, like back before .NET Core in the .NET Framework Dark Ages, there was a CS proj, and you would open it, and it was big and ugly. You'd do file new project, and it'd be like 120 lines long, filled with XML that was painful to look at, painful to read. No one wanted to touch it, so everybody just backed away slowly. Around .NET Core time came around, MSBuild went cross-platform because they had to in order to support actually building it, because it's great that C# is cross-platform, but if your build system isn't cross-platform, that doesn't do you a lot of good. So MSBuild went cross-platform, and then right about that same time, Microsoft introduced what they called the SDK project in CS proj. So for people who are unfamiliar with it, if you open up your CS proj file and you see a little SDK attribute right at the top underneath project, you're using an SDK file format. And I think, don't quote me on this, I think with the next version coming out in November, I think the last remnants of the old CS proj will finally die. Most project types have finally converted over to it. So most of the time when you do file new project, you aren't dealing with the old CS proj. There are a handful of them that have been holdouts, and I think the remaining ones are going away. So unless you're targeting some old framework, you shouldn't have to deal with old CS proj anymore. So we'll get rid of PowerPoint. As you can see, I had 0 slides because slides are boring, code is fun. So there is a repo I have out on GitHub. Don't get too excited. We'll come back to this in a moment. And underneath this, we're going to take a look at actually building out and doing work with MSBuild. So we could start this with a CS proj and work from that. But as we'll see in a little bit, the CS proj, especially the project SDK format, comes with a bunch of extra stuff. And so we're going to back all the way out and start with MSBuild proper. By itself, if you were to write something from scratch, what will it work? Just like kind of learning to code, oftentimes we start with our bare building blocks. We start out learning if statements, methods, for loops. We're going to do the same thing with MSBuild. Everything in here, even though this isn't necessarily going to leverage C# code, you can apply this to your CS proj formats, your VB proj, your FS proj, your whatever other proj file they have. Secretly, MSBuild is perfectly happy with anything whose extension ends in proj. So CS proj, FS proj. So you'll note, in my case, I named it my proj, just to really hammer home the idea that as long as the extension ends with PROJ, it's perfectly happy to play. Inside of this little project, I have decided that what I'm going to do is invent my own programming language, because that's what we do, obviously. And unlike a Microsoft C# compiler, CSC-exe, I've written my own CSC-exe. It's called Can Someone Code. It seemed appropriate. As you can see, it is a horribly complex application where if you're unfamiliar with system command line, the entire meat of the application is those little lines down near the bottom. And as you can see, it's a very simple thing that just personally hates me and everyone else named Kevin, which is great. But that will be our compiler. Don't need to concern too much about it, aside from the fact that it does some logic, writes some stuff to the console. We're going to pretend like writing to the console is compiling our code, because we don't actually care about what the compiler does, mostly how to do it. And you'll note for my files, and again, just to hammer home that extensions don't matter, I've created 2 files with a .coder extension on them. One for Team 1 that contains Adam and myself, and then one for Team 2, which contains Cameron, and because I didn't get another volunteer, other Cameron, because I needed 4 names, and, well, other Cameron was going to have to work. But for our purposes, we are going to work on building out this little CS proj, and we are going to just change the language mode. I guess most people can't see the syntax highlighting, but I can see it there. So from our command terminal, I'm going to make some sweeping assumptions for this talk. One, that you've installed the .NET SDK or at least MSBuild on the command line. Either one will work. When you run the .NET SDK, several of the commands will actually forward straight into MSBuild. So .NET Build, .NET Clean, .NET Publish. A lot of these ones are just forwarding straight in to MSBuild under the hood, but they give you a nice, pretty way of doing it. So we will start with .NET Build. We run right into our first error. The key thing to note, most of us are used to seeing compiler errors come through this way. If you're unaware, this prefix actually gives you a strong hint as to where the error is coming from. So something that starts with MSB is an indication that the problem is inside of your build system, inside of the MSBuild script somewhere. And in this case, it's pretty obvious. There is no target in the project. Given the fact that my project contains empty, I think that that is a pretty reasonable explanation. Inside of MSBuild, there are roughly 3-ish types to play with. You've got targets, which you can almost conceptually think of as your methods that you get to invoke. You have collections or item sets, and then you have properties, and that's it. And MSBuild is built around those 3 things and building up pipelines through each of them. So we go through, and rather than watching me code, I have cheated and written branch pointers. Whoa, look at that. All that code so fast. Let's get rid of some of this stuff. Test to make sure it fits on the screen. It all fit on the screen, and then somebody told me that my font was too small and I had to make it bigger. So I made it bigger. So some of this stuff will probably look very familiar to people who have opened up their CS projects inside of Visual Studio. Within VS 2019 and newer, if you double click on any project file that's following the SDK project format, you can just double click, open it. Visual Studio is really hip to the idea of giving you a cached copy. You can edit, save, and then it does the swapping under the hood for you. Everything else you have to unload and edit as regular XML. But in terms of those 3 types that I had mentioned, we have properties, which in this case, we just have a single property that's going to point to our CSC path. So again, this is my Can Someone Code exe, not the real CSC. We have item groups, which again, this is probably fairly familiar to a lot of people, where we're just saying, hey, search for every subdirectory, find me a .coder file, slurp that up. Inside of your CS proj, there's a bunch of defaults that people are probably used to seeing, mostly .C# files inside of CS proj get picked up and get fed into the compiler. This is ultimately how those types of things work. And then finally, we have a target named build. And then inside of the target, it does a bunch of little tasks. So the first one is the message. And if people are interested, there is on the repo, I linked out to a whole bunch of documentation. There is way too much information on MSBuild out on the docs page. And this document is actually really, really good. Unlike a lot of documentation that's horrible, this one's good and is actually useful and contains useful examples and everything. But specifically down underneath the MSBuild reference, if we end up looking here, this task reference, if you're curious all of the tasks that are built in that you can play with, there's a long list, especially with a whole bunch of examples. So if we just take a look at the message, we can see that the message takes two parameters, text and importance, where importance is high, normal, or low with a default of normal, which is great. So we have starting build, importance of normal. We do some reading from a file. Then we do another output just to say, here's where the CSC is that we're going to use. And then we invoke it on the command line with an exe. Now there's kind of a bunch of stuff all happening in here all at once. So I'm going to throw a bunch of syntax at people and then kind of brush over it and say, watch, it works. Because unfortunately, me explaining a bunch of this syntax doesn't matter to a lot of people until you actually are in a state where you're going through and editing your CS proj. So I'm less concerned with people knowing syntax and more knowing what's there and what's possible and knowing where the docs page is to look it up when you need it. Because most of the time, this isn't something that you necessarily need on a day-to-day basis. So first thing to call out is this little % sign here. So the magical keyword here under MSBuild is called batching or bundling. What this ends up doing, it's kind of like a loop. Emphasis on kind of. It's not quite the same, but it's pretty close. What it will end up doing is saying, okay, find everything in the coder's set, and then the dot identity is one of the magical MSBuild metadata attributes on it that just is the equivalent of like the this keyword in C#. So iterate over all of the identities, the this portion of it, and spit those out. Those ones get fed into the read line, and as this indicates, it will read the lines from the file. That's one. The key part here is it's outputting, and this output here, you'll note it's writing out to this item file. Now, this item group doesn't exist or isn't declared anywhere. MSBuild is sort of like, I'll say like JavaScript, where you can wish variables into existence, and they magically show up. This is wishing items from file into existence, and it magically shows up. The problem with this is if somebody, hypothetically, while trying to put together his demos, leaves off an I, well, that's no good anymore. It stops working. And you don't get a lot of explanation aside from it going, yeah, that was an empty string. I don't know what to do with empty string. It's like, oh. So be aware that because things get wished into existence, there's no concept of does this thing exist or not. You can check for is it empty, which is oftentimes used for checking for existence, but there isn't necessarily a way of saying, give me exact things at use here. Up here, I'm going to call out this little bit as well. So for people familiar with .NET, that should look very familiar. Path class that we all know and love for building up our path strings and getting the fully qualified path of something. This is just simply taking my relative path, looking up the full one. You can see I just did a regular .NET publish out to get my CSC exe. You do not actually get access to all of .NET Framework inside of MSBuild. Well, ish. The functions that you are allowed to use are very limited. There is a finite set of like 30 or 40 of them that you can use, specifically like 30 or 40 classes and then everything underneath it. So system io.path, system environment, some of the common ones that you might expect that you might get to use is underneath the registry. Caution with using that. You won't be cross-plat if you do. Those types of static methods accessed and can make your life a lot easier. So if there's there's a really nice C# method. Well, oftentimes the stuff that you're doing inside of MSBuild involves file I/O, mixing files, pulling environment variables, that kind of thing. Those functions are available for you. Okay, so let's go down here. So proof is in the pudding, .NET build. And Right there, we question why, oh, the system cannot find the file specified. So it's almost like my CSC doesn't exist. Stand by one moment while Kevin remembers the magical command that he needs to run to compile CSC. And that doesn't work from that directory, but it does work from the root level directory. Hang on while we quickly compile our compiler. I made the mistake of updating all the things and running a git clean to make sure I was back in a nice fresh state, forgetting that a fresh state meant that I deleted my compiled version. Thinking. Optimizing, linking, stripping down to a standalone exe. Excellent, thank you very much. Okay, don't make a liar out of me. Wow, that's a lot of stuff. .NET Build. Hey, look at that. That looks kind of like what hopefully was somewhat expected. So you know, 4 lines of output. Apparently I'm the only one who thinks he can code. Even other Cameron's better than me. Great. Close that guy down. But hopefully this makes at least a little bit of sense in terms of readability. Now you'll note that we had a couple message things here that didn't end up showing up in our output, and their importance was set to normal. So let's go through and change one of these things to high. HIGH, height. Spelling's hard. There's a lot of eyes watching, and I just can't spell. So now you'll see it coming out. So underneath the hood, when .NET Build is calling out to this, you might note that, oh, well, you're calling .NET Build, so clearly it's landing on the target build. Not build. Let's try this again. You'll note still ends up landing on it. So the targets that this thing ends up picking are at sometimes considered a little bit arbitrary. So right now, what it's doing is if there is a single target and you haven't told MSBuild which target to launch, it grabs the first one, and that's the one we're going to use. In this case, it's the only one, so it happens to be right, which is great. In terms of the output, there is a verbosity, and I'm just going to use shorthand. And -v for verbosity, -n for normal, because by default it is set to minimal, which only shows you the high stuff. But you'll note now we are actually getting the rest of our output. So we can now see that, oh, look at that. There's my using CSC with my fully qualified path and lots of information in here. Oftentimes when doing any work on MSBuild, it's very easy to get lost and confused as far as what is actually happening. Dropping these message tags in at different places to figure out, hey, what is in my set? What is my variable? Why is this thing not behaving the way that I expect is great. But printf level debugging, just like in C#, though it works, isn't always the best idea. Like you can certainly do printf debugging, and we've all done it at some point in time. Sometimes it is a legitimate option when you are frustrated and have no other options. But Microsoft has given us a much better option. So if you tack on the -BL, so Bob Larry, on the end of it, that's for binary logger. And there's a similar switch that you can pass to MSBuild at that level. But what it ends up doing, besides this extra little output that it ends up generating for me, if I go and look inside of my custom project, you'll note I now have this msbuild.binlog file that exists. And this guy here. So Microsoft has released a binary and structured log viewer. This thing's existed for a little while. What is fairly new is the fact that it's a completely web-based application. So if you don't really want to install anything and you just want to debug your stuff, you can just go straight on into the web-based application and upload it. Now, before you do this, and there are a bunch of warnings on their site and about this, there is a lot of information that goes into these binary logs. Like, for example, your environment variables. Now, you can think of several applications, cloud-based applications, that may store credentials or tokens or secrets in your environment credentials. You might be conscious of that before you just upload your bin log file to the web. So the Microsoft site isn't going to do anything nefarious, but it is now taking potentially secret variables and sending them outside of your machine. If you would prefer to not do that, you can install the local viewer as well, which we have here. And if I, best part, you can zoom, and there is a dark theme in this. I will not show it to you because the selection theming makes it impossible to read, but it has, which is important for all developers. So in terms of actually going through and debugging your build process, this now actually gives you a reasonable way of taking a look at it. So rather than just doing printf level debugging, where we're dropping stuff out to the console, we can actually take a look. And you can see in here, there ends up being a few extra steps that we didn't actually count on. So one, there's your environment variables. I'm not going to scroll because I don't know what's all in that, and I don't really want to expose that onto YouTube. So we are not going to do that. But we can see that it executed example myproj on a restore target. And then if we look down here, we can see that it actually went and executed the not build target underneath myproj. And with inside of that, we can actually start going through and finding out, okay, what are the tasks that we ended up doing? For example, the read lines from file, I can now go through and look and say, oh, what did that actually do? It read the team1 coder file, and it wished the items from file into existence, and it added in Adam and Kevin. That's kind of convenient. And then it executed again due to the batching, came in, pulled in a few more. Especially when you're fighting with build problems and trying to figure out how to customize or change. This can be an invaluable tool. This is awesome. I ended up using this last week when I was fighting with an issue where I wanted to be able to target .NET Build against the solution file and exclude a project from the build process. This is how I tracked down what to override, what to change in order to figure out what the build process was in fact doing. So, binary logger is your friend. We are going to make great use of this in here. Questions? It's okay if people interrupt me. I actually enjoy it. No? Okay. I'm happy to talk too. I do it a lot. For whatever reason, people let me. Oh, hey, you. Go away. Don't want your changes. Change is bad. Okay. So let's carry forward. So now we're going to jump forward in time. We've done a little more building out on our proj file. So you'll note before we ended up, go away. We ended up just letting it land right on our first target. But now we've gone through and actually built it out a little bit further. We no longer have just our one build target that we were building on top of. We actually have a bunch of targets. We've got a before build, a build, an after build, a clean, and some other stuff for compiler and read coders. We've got a bunch more properties built out. What ends up happening is with the targets, there are multiple ways to specify what to run. You can almost picture these the same way a lot of unit test frameworks work, where there's usually some sort of like setup that you can do and then actually run the test. So if we treat our targets like we would a method or a test, the default targets tell it which one to run if we don't specify one. And then more importantly, there's also an init targets. So if there is some sort of target that needs to be run like for setup or similar to do some work, you can set it up there as well. The other thing that's been subtly introduced into here when MSBuild fires up and starts running, it does things in two passes. So the first pass looks at all of your files, figures out what is the sum total of everything that's there. Because right now I've got everything inside of just one file. In a little bit, we'll see what it looks like to actually bring in multiple files. And more importantly, share code across each of them. But when it's building these things up, it has to build effectively a dependency tree between all of these targets to know which ones actually get built. Because in order to run the build, which is now my default target, I actually needed to do a couple things. The before build is a little optional. It's just a message. But we've got this, compile my coders and read my coders and all of that extra work that we want to do. And that all needs to happen before I can actually feed stuff in to my little CSC that I've built out, which is important to actually get all of that set up. So when going through and setting things up, oftentimes if there is something that you want to inject, because this before and after targets just takes the name of the target that you would like to inject in on, you can actually leverage this to add in your own targets in your CS proj to run as part of the build pipeline. So for example, inside of Visual Studio, if you go with your latest project properties, there are, underneath the build, there's a couple boxes for before and after build targets. And you can type in some commands in there, and all it's going to do is generate a target inside of your CS proj and put whatever command you did inside of that target for it to execute, which is great. So if you want something to generate and set your either before targets or after targets, Visual Studio will go ahead and do that for you. The other thing I want to call out is this combining of these properties in here. So you'll note that I've started to structure this kind of like what people might be used to seeing inside of a CS proj or similar. So we've got an intermediate output directory. That's our OBJ, hypothetically speaking, right? Not that we've all seen this in our C# projects, which is just a directory where MSBuild ends up putting stuff as it's building up its process of doing the full compilation. And you'll note down here, I've got this concat file that I've started putting together that ends up just putting full team.coders. So in this case, what we're going to do is we've got a bunch of team file or a bunch of coder files that contain the members of different teams. And really, for this compiler, what's important is to just concatenate all of those things together and dump them all out. That's really all we're doing is writing things out to the screen. I'm lost. So what we've changed under the hood is this compile coders, you'll note, is somewhat similar to what we were doing before, except for rather than reading those lines and wishing them into a variable, we're reading the lines, wishing them into a variable, and then outputting them to our concat file. And you'll note what this ends up doing is reading two separate files and then doing a single write out to this file and just blindly overwriting whatever's there. Now, the one nice thing that this has now started adding for us are these inputs and outputs. Some people will have noticed that sometimes you hit F5 and it seems like Visual Studio goes really, really fast and just app starts up. And what's actually happening under the hood is the build process keeps track of what files are used as inputs, what are used as outputs, and which ones have changed. So oftentimes, and sometimes bite you, it ends up leveraging the modify date on the files. So hypothetically, if you have a particular source control engine that likes to modify the modify date on files, this can mess with MSBuild a little bit and either make you compile too much or not at all. But what it'll do is keep track of which things have changed and then only execute those targets that are actually needed. So this is often referred to as the incremental build process that you'll see get referred to inside of Visual Studio and the MSBuild docs, which can be really powerful unless you are trying to inject yourself in on a target that ends up not running all the time because it has inputs and outputs. So keep that in mind. Let's actually see that go real quick. So I'm going to go .NET build, binary log, great. And then I'm going to, for Bost normal, dump out a whole bunch of stuff. And you'll note, skipping target compiler coders because all output files are up to date with the input files. So because I haven't changed any of my input coder files, these things now just work. Now hypothetically, we realize other Cameron, we're just getting rid of him. Now if I go through and rerun this, we scroll back up, you'll note now we don't see that same thing. It actually went through and executed the compilation of that task. Compilation, very loose usage of file concatenation here. But now it's actually put it through. Do it one more time. And we see we ended up skipping it. This is incredibly powerful. especially if you're building up something as part of your build process. Imagine hypothetically on a post-build step, you want to copy some extra files over. Now there's a magical metadata called preserved newest that you can use to have MSBuild leverage it for you. But if you wanted to do extra logic and determine when you're going to copy your inputs and outputs, will then communicate back to MSBuild whether it actually needs to invoke your target, which can be really awesome, especially if you're trying to leverage data coming from potentially outside your repository. This can save you a lot of build minutes and a lot of build time. You'll also note it now wants to dump out this detailed build summary, which great if you want to measure timing. I don't care. The keynote, in order to see that, the binary log with verbosity normal is what's triggering that, by the way. So we can, dropping either of those makes it go away. We'll go ahead and put other Cameron back. He can stay on the team for now, just for a little bit. Let's see. The other thing I'm going to mention down here is this clean target. Again, this I have, here, we'll bring that up higher. I've cleverly gone through and built stuff out that matches what's inside of your CS proj in the .NET SDK for what it's doing. The fact that these names happen to match is clearly circumstantial and based upon the fact that I was drinking Mountain Dew and was not feeling creative. But if we want to actually go through and invoke the clean target, there are a couple ways we could do it. And you'll note in this case, our clean target is only going to do a couple things. We've got our little OBJ directory, which we can see our team of coders that are currently in there. And in this case, clean is just going to print out a message and whack the directory. Nothing overly fancy. And if we want to go through and do it, option one is we could just run .NET clean. And poof, goes away. Directory disappears. We see the output in clean, removing OBJ. We can also see some extra output there. The other option we can do is so let's build again real quick just to get our OBJ directory back. The other option is we can actually very specifically tell MSBuild, this is the target I want you to run. Now, you'll note before we were running .NET Build, which was letting MSBuild figure out what target we wanted, which was either picking the first target in the first example or going with the default target. Yeah. If I run build twice, still works. Was there something else we were expecting or hoping? Same, and actually worth noting too, if you run clean twice, you'll note it's actually intelligent about the task underneath there of going, hey, that directory doesn't exist. Maybe I won't spend time deleting it, which is awesome. MSBuild is very much optimized for these types of operations because this is what it does literally for its day job. But if we go back to our build, if we want to actually end up specifying a target, it gets a little interesting because if we go .NET build -- help, we'll see a whole bunch of stuff here. And what's not overly apparent from any of this magical stuff is all of the options that are available underneath MSBuild, because this is very much a subset of what's there. The nice part is the .NET SDK, if it doesn't find something that matches, it'll go, huh, I wonder if MSBuild wants this, and just shovel it right on down the pipe to see if it works. So if we take a quick look, I'm going to cheat and pop a developer prompt. Boop, boop, be big font. MSBuild.exe. And yes, you do need to do the /? because MSBuild is old. It is old. So down in here, we get all kinds of extra options. And specifically, MSBuild lets us go through and actually figure out, hey, what target do we want to run? And I won't bother spoiling a lot of them. The important ones that people tend to use are target, property, and sometimes max CPU when MSBuild isn't using enough CPUs and you want it to consume more. Target one, we can actually tell it, hey, by the way, .NET is helpful. It's pre-canned to say, oh, when somebody runs .NET clean, I know, the .NET SDKs always have a clean target. Let's go and hit that. If we actually go and run it ourselves, so I do not know why it keeps jumping to the bottom. Please stop doing that. Please stop doing that, terminal. I love you, and I don't want to hate you today. If we come over here, because I'm just going to call out here, the short form of this is -t. Right? So that's, I'm just going to abuse that a little bit. And you'll note, there's no -t over here that could match, because you can run into problems. So if I do -t : clean, you'll note I now executed my clean target. And the syntax starts to look a little weird because I'm now mixing normal .NET SDK CLI commands and build commands. And just leveraging the fact that I know that .NET Build will just shovel things down the pipe. I believe, if I'm not mistaken, you can also very explicitly do that, and it will not do what I expect. So that is old syntax, and don't trust me on that. Yeah, we'll go with that. The other one that's actually quite common for people to want to do is actually go specify properties. Because you'll note up here, I've got this intermediate output directory that I've just hard-coded to OBJ. But quite often, people want to be able to do things like conditional compilation. Everybody's always seen like the poundif debug, or I should say some people have probably seen poundif debug littered in some C# code bases. All that is a compile constant that's passed on to CSC exe. But in order for that to be defined, something had to pass that into the compiler to say, hey, by the way, these are some constants I want you to know about. Now, most people are just used to the little drop down in Visual Studio. I've got debug, I've got release. That's great. When you change those configurations, what MSBuild is doing is it's going, I know what that configuration is. I'm going to define some additional constants that I'm going to pass to the compiler. And that poundif debug isn't limited to just debug. You can have it define any number of things you want. You can make up your own text, which I've done on several projects. But the problem is once you have MSBuild defining those things, oftentimes you're going to want to compile and hit against it and set that properly differently. So you could imagine I might have a constant that I want to define that says, hey, hypothetically, rather than debug and release, I want to have a publish debug release. How do I specify publish? That's not a normal thing that's in there. What you can end up doing is specifying your parameters with just the hyphen property, or my preference, -p underneath the hood to go through and specify it. Questions? No one's asleep. Okay. I'm going to keep going then. I'm going to keep going. Okay. So all of this is well and good, and we've built out this nice little compilation process. But ultimately, that's not what our CS projects end up looking like. Everybody's seen the brand new CS proj, and it looks a lot more like that. In fact, we can probably even get a little more fancy and get rid of this. Imagine a lot of people's CS projects have a project option, an SDK attribute, and usually about 2 or 3 properties that toggle you between whether you're generating an XC and a DLL. And I don't remember what the other one is. I think there's only 2 that are in the default project template. Microsoft has stripped it down to almost nothing. But under the hood, there still needs to be something to tell MS what to do, which is where that SDK attribute comes into play. And most of the time, you'll end up seeing, trying to remember the name of the Microsoft one. Microsoft.sdk.web, I want to say is the ASP.NET Core one, and I can't regular C# one. But those magical names under the hood to SDKs that are installed when you install .NET SDK. So underneath your install directory, so C:\program files, .NET/SDK/insert name here, is where you'll end up finding the files needed for those SDKs. And MSBuild does not care a lick about file extensions. All it cares about is that it finds files and that they're shaped like these XML things and it can read them. And then it's happy. Now, by targets and props to try to indicate this subtle difference between the behavior in them. The props typically containing your property groups and your item groups, and your targets containing the targets, the things that you're going to run. The other subtle difference that ends up happening is there is a 2-step process that occurs inside of MSBuild. Doing that evaluation and pulling everything in You can think of that as early in the process, and then the execution phase at the end. And because order is really, really important to MSBuild, things, or I should say targets that are defined later override targets that are defined earlier. So if you're able to go through and actually define a target with the same name as something that was defined earlier, you'll override something that was there previously. Now the problem is this little SDK attribute. There's actually multiple ways to define this. The easy one is just an attribute here, but that is actually identical to SDK, trying to remember, I think it's name custom SDK version. And version is only required for custom ones. The Microsoft ones, they get to cheat and omit that because they're special. So setting the attribute and setting this one here are both identical, but both of these end up being equivalent to two import statements. So import, and I'm just going to do this as a comment because, let's see, source props file. Why are you so unhappy? There you are. Thank you. Targets file. So when you define either the SDK element or the SDK attribute, what ends up happening is it inserts an import for the props file for that SDK at the top and an import for the relevant targets files for that SDK at the bottom. And all of your code from the CS proj goes in the middle. What's important there is that if you define something that has the same name, hypothetically the target name build, you are not going to override the SDK build target because its import is going to always be at the bottom. And so there is no way using either of those two syntaxes to go through and actually override it. Now, what you can do instead is drop the SDK attribute, drop the SDK element, and just write the import statements yourself. And at that point, you can now move things up and down, put things wherever you want, override things, come in behind, change things, and now you're in complete control of it. And at the end of the day, it's no different than our previous example that we had where we were building out our targets with everything in line as we went. You're now in complete control. The MSBuild system is not overly complex. What makes it complex is that the SDKs tend to have lots of files in them. Lots and lots of files. So, for example, let's run a build here. Whoop, not you. You. Clear, .NET build. Let's not do clean. Let's just run. Okay. Oh, and actually, let's do this. Binary logger. Show me the output. Then I come in here. I press F5. Okay. You'll note inside of here, there's all the same targets that we were expecting from before. Secretly, what I have done is I have moved my SDK over here. You'll note there is a props file. Contains a lot of the exact properties that we saw a moment ago, along with our item group. And then you'll note there's the targets file with very similar targets to what we had before. There's a couple subtle differences that are happening inside of here. So for example, you'll note this logging verbosity. If we look at our targets, we'll see that the importance level of each of our message tasks are using that property. And then over in our props file, we aren't blindly setting this property anymore. We're being a little more intelligent. We're going through and saying, okay, if the current value of logging verbosity is empty, meaning it hasn't been specified, let's go ahead and set normal on it, just to make sure that there's something worth setting in here. Which means we're only going to set it to normal if there isn't already a value specified. Which means I can come back over here, because I don't trust myself typing right now. If I do a property group, boom, I can do logging verbosity, high, boom. Yo. Out of what? Oh, improt. See, but now I can't unsee it is the problem. See, it was up there and bothering you. I understand it would have been bothering me too. So I'm just going to subtly put it inside of the comments where this thing would end up getting placed. And now if I run my build, you'll note we end up seeing a little bit more output than we did before. Specifically, the before build message now shows up. The building with my CSC path shows up simply because I've now overridden this variable that my SDK is using. There's a lot of variables built inside of the Microsoft SDKs. And oftentimes digging through the docs with a binary logger are some of the only ways to end up finding them. But that's why in your CS, when you go through and define some magical properties, things magically start getting picked up and used. Is under the hood inside of the SDK, there's logic not too unlike that to be able to go through and specify it. More, yeah. So it works like CSS. Yeah, in the ways. Whatever you define there overrides everything else above it. Yes, with the one exception, because the targets file of the SDK is coming in last, its targets are going to win out, and more importantly, overwrite yours. Trying to build target here, the one inside the SDK is going to win, not us. Now I can define my own target. So for example, I can go target name foo, because that's the appropriate name. Come on, tab. I know how to type. Message text gets Austin is right. And we can do something like after targets build, because we know there's a build target in there. And turns out you do have to write valid XML. It is unhappy if you don't write valid XML. And where'd we end up going? Oh, we ended up not landing in there at all, did we? Oh, because we can't, because we are still being defined before, and so we won't exist at that point. That's exciting. That is very exciting. So, well, when demo goes poorly, you go into your example and end up showing why. So there is your foo target showing up after the build. Why the verbosity? Oh, the verbosity didn't show up because we don't have it set to high. That's why. Importance high, because this is very important to get output. Huzzah! There we go. Okay, now I feel better. Worth noting, you can specify both before and after targets if you really want to. If it's really important to you that, hey, I really need to be between these two things. You can get yourself in a situation where you define a dependency graph that is not possible to be executed, in which case MSBuild just blows up in your face and says, yeah, I can't do that. That doesn't work anymore. But you can build it out there, and then more importantly, debugging your step all the way through. The other thing I will call out is over on the left, this little files. If you run the binary log against the Microsoft projects, you are going to see a ridiculous large number of files in here. And you'll get to see how many ways they do imports and how many MS builds and how everything flows back and forth. And it's quite enjoyable to look at. What's kind of convenient is you can just click on these things to dive into the files, though. If you want to see what's in here and figure out, hey, what is this target doing? Because I'm sure we've all seen various builds where we've compiled against the SDK and we've gotten some weird error. Like, for example, that's the other one, target framework. Right? If you don't define a target framework in your CS proj, you end up getting a compile error because it goes, I don't know what to do. You gotta give me a little bit of information to work with. What am I targeting here? What is actually happening under the hood is there is a target that pulls in that property and says, I need to make sure that the target framework you specify is one that's on the list I know about. And if not, I'm just going to throw an error. And if you want to go through and see it, you can walk through and take a look at it. The other nice part is this find in files as well as this search log. So just going to call out these wonderful options here that are built where you can actually start hunting for things like show me the errors, show me the warnings, and start filtering your graph down in your process. Because if you've ever run a .NET build and set verbosity to detailed, you'll note that it's about 80 billion pages long. And you see every target and every little bit of output, which is nice until you're like, I need to find where it invokes this one target that's failing. And sometimes you can scroll and find the big block of red, and that's helpful. And other times it's not coming out as a block of red, and it's really frustrating to find. This is much more helpful. Because now we can actually dive through and say, okay, let's start looking for certain items of a particular kind that I'm looking for. I'm looking for just error outputs, or I'm looking for just CSC calls, because I want to end up seeing what's actually making its way into there. And in case it's not obvious, if you want to roll your own SDKs, that is a thing you can do. Very few people do it. Very few projects do it. It is possible. The one repo that I will call people's attention to is this one right here from Microsoft. So Microsoft has the MSBuild SDKs. So a lot of cases that people end up wanting to leverage stuff for, there's already an SDK built for it. Now, these aren't necessarily ones that are always in the box, but you can pull these things in. As you can see, there's NuGet package references for them. And you can reference them the same way I was doing it, as a NuGet package name / version. The secret trick that I'm leveraging is I just have a local NuGet source that is this NuGet folder, which is where my NuGet package is landing. Dirty tricks. But I'm just using a local NuGet. You can pull from a regular NuGet package. But things like the Microsoft Build no targets, a project where, hey, I want to avoid, like, I want a project, but it's only going to be copying files. It's not actually going to do a compilation. Most of my custom SDK that we built tonight would pretty much fall into the no targets in a lot of cases. I'm concatenating some files together and writing some output. It's nothing fancy. It's almost like there's no assembly to compile, hypothetically. Another common one is the build traversal one that gets leveraged a lot. Oftentimes in pipelines, people really like targeting their solution files, because my solution file contains the set of all of my projects. I want to compile all the things. I want to ship that. The problem is the solution file is, one, a little unwieldy to work with because it's a pain to edit. And two, the solution file is designed to be a target for Visual Studio. It's designed to basically be consumed by developers. It's not necessarily designed for something to be used in a pipeline. So the Microsoft Build Traversal one is designed to be the, we'll say, solution file equivalent, but in a friendly way where you can use the MSBuild syntax, more importantly, than just target it on a pipeline. So if you want to have effectively a solution type thing that just builds up a set of projects, because perhaps maybe in your solution file you have a bunch of stuff that maybe I don't want to build, right? Maybe I've got this database project inside of my solution that I'd really like to keep there, but I kind of have to exclude it if I want my pipeline to do a .NET build and target the solution file. That's a pain. You can go through and put together a very simple project with this, do project references like you would normally, and then have your pipeline target that. There's a small question about keeping it up to date when you add new projects, but it's one project reference. Somewhat simple. So for people interested in taking a look at this central package versions, this one has existed for a while. I will call out, if people are interested in something like this, there is actually a NuGet feature that is preview that you can leverage instead. Both of these come with the same drawback of, if you manage your NuGet packages this way, you can't use the GUI in Visual Studio to update your NuGet packages, which is kind of a big drawback, because a lot of people like to just right-click, update NuGet packages, and have things work. Kind of both the NuGet solution as well as this basically make you end up managing this locally yourself and setting it. But it does give you one centralized place for, hey, when I want to rev my newtonsoft.json package, I change the version once, all the places get it, everyone's happy. The last thing I will mention as well is there are a couple magical files that MSBuild will end up going and looking for. So for people who unfortunately sat through my calamities talk several months ago, where I tried to abuse C# as much as possible, one of the things that I cheated with was a directory.build.targets file. So directory.build.targets and directory.build.props when MSBuild runs, it walks up your directory hierarchy looking for files with that name. And if it finds one, it goes, ooh, let me include that for you in the set of files I'm going to use, which can be great because now I have a way of bringing in some common MSBuild like properties files. Maybe I want to go through and set my debug type on all projects to portable. Well, I can just put that in a directory build.props file at the root of my repository. Poof, all of my projects now have that file included, which is great. It's a nice, easy way of having some combined logic without having to write a bunch of imports to make sure this file references that and all of that. The drawback is it can also be somewhat difficult for somebody to debug if they don't know what they're looking for. So be aware that those files do exist. There's one other one that rarely ever gets used called response files, so .rsp. All of those command switches that we saw here, for example, like max CPU count is a common one. Somebody may decide at some point in time that there is a set of switches that every time MSBuild is invoked, I always want to set max CPU count to 4, right? And I don't care where MSBuild is invoked from, how it got invoked. I just want to always append that attribute onto the end of it. There's a directory.build.rsp file where you can just basically list all these command line arguments. Again, that directory.build.whatever, if you see those, just assume that those things are magically being included due to folder structure. Okay. With that, I'll wrap it up. Questions from people? Was this helpful? Was this useful? Does MSBuild seem as scary as it once did? A little less scary, hopefully? Use the no targets instead of PowerShell. That sounds much better. I've seen people actually go to the effort of like .NET new up and edit the CS proj and all kinds of weird XML-based stuff. Like, oh, please stop doing that. Please don't do that. That's bad. But these are just NuGet packages that you can pull in, and if people want to build their own fancy little bit of MSBuild and package it up, you certainly can. There is one, the only thing you have to do special on your NuGet package is in your new spec, you do have to flag it as an MSBuild SDK. Other than that, it's just a normal NuGet package where you put SDK props and SDK targets underneath an SDK folder. And that, when in doubt, the Microsoft repository here is actually a wealth of good examples of both how to build one of these things as well as how to consume them. So their samples have a lot of great bits in there. And again, the MSBuild docs out on Microsoft's site are exceptional. Like, I'm sure most of the time I could go through and show you, okay, here's how you set your items metadata and all of that. That will probably not matter to anybody, and you will forget it by the time you need it. So just know that the answers lie here, and that these docs are very good and up to date. Other questions? Concerns?
Example. So if you went into your SDK folder and wrote a target, that would go, right?
So
You could update your SDK right by currently networking because you took a name.
So yeah, so the question being, if my SDK ends up declaring a new target that that somebody else has already declared inside of your CS proj, could you end up potentially overriding theirs? Answer, yes. A lot of the Microsoft ones, you'll note the stuff that's supposed to be deemed private, because these targets don't have like access modifiers. As far as it's concerned, it exists or doesn't. The ones that are supposed to be private and usually an underscore prefix, just as a way of trying to differentiate them. So I would encourage you to not lead with an underscore prefix, because that is the most likely way that you're going to run into them. A lot of the other ones are going to probably follow most well-known names that you are familiar with, for what it's worth. In general, just picking a name, because this name doesn't actually matter as long as this name is correct for your after or before targets. That's what's most important. So I can go here if I'm really worried about stuff. There, I'm pretty confident I'm never going to run a muck of somebody. I mean, maybe it's on YouTube. Somebody can go build an SDK with that exact name of the target. It's not a great name, but they could.
So if you paste
Mm.
Your custom SDK or
Yeah, so if
enrolled Austin is wrong. Print that out, right?
so if we come in here and something like this, apparently I can't copy, paste, Austin is wrong, right? And then it's almost like somebody has a nice little command that automatically updates his NuGet package. Not like he was worried he was going to need that or anything. So you'll note Austin is wrong. But in this case, Austin was correct that then my local one would not get executed. And again, it's all about that order of operations of where that SDK gets brought in. Because the convention for the SDK attribute and the SDK element are bringing the props at the beginning, targets at the end, it means they get to win. But you'll also note that inside of, for example, the Microsoft one, like if we just look at the no targets really quick, this guy here. So you'll note what they end up doing is they actually very explicitly end up pulling in the SDK targets for the Microsoft.NET SDK. So they're very explicitly putting in the import statements specifically so that they can be either above or below it, depending on what's important for what they're doing. And then in a similar vein down here, there is another one for importing the, yeah.
So if you
Did I miss it somewhere? Is there another SDK reference in here? SDK dot. No, I don't see it. It looks like they just dropped in the props altogether from the SDK because I don't see an import. Normally, I would expect to see an import project SDK props somewhere in here as well. Oh, actually, that's a good point. It's probably in their props file. Yeah, I didn't just do that. No possible way. Yeah, so there's your SDK props ones in here. And you'll note they are also putting conditions on here, very explicitly saying, so they have a value up above. So this Microsoft common properties have been imported. This is the one from the Microsoft SDK. But one of the common things that you'll note is they declare this property here, simply so that they have a way of checking, hey, have I been imported already or not? So it gives a nice, easy condition. So if somebody starts combining multiple ones of these things together, it doesn't try to import twice, which can be quite handy. Oh, can you have multiple SDKs? Yes, kind of. You have to be a little careful on how you bring it in and do it. So I can probably find you an example. I have one where I pulled in, so the Razor has a MSBuild SDK that it uses. And I was in an Azure function. You can cheat MSBuild a little bit to pull in the Razor SDK. On top of the function, your project still has to target the Azure Functions SDK to actually compile correctly. So you can kind of mix and match a little bit, but oftentimes when you start to getting into those cases, those are usually not overly well tested, and it's easy to accidentally shoot yourself in the foot, for what it's worth. But it was totally cool when I got Razor working inside of an Azure function. I was tickled to death. But once again, binary log took a while to figure out what needed to happen and what was broken, which is not always a trivial thing. Great question. What else?
Back to the food example. If you use import source in there, and now we know the targets file is coming in afterwards, can you use that import above it to?
Oh, could I just import the SDK up here to let mine be? Yes. So you end up having to drop this though. So So the question being, as far as bringing in, and if I wanted to make my target override the one from the SDK, you end up having to drop the SDK attribute and make sure you don't use the SDK element and manually do the import yourself. Again, very, very similar to what their no targets one ends up doing, where they're manually bringing it in at the point that they want so that they can appropriately override stuff. Because down on their, I will find it. So you'll note they are intentionally putting the core compile, which is the Microsoft target that actually usually does the compilation for it. Very specifically, they're saying, yeah, by the way, do nothing because this is, no build. But very intentionally putting that in after wherever that SDK targets was. So the same thing of what you were asking. As long as you do the import first, now I can drop stuff in afterwards and override whatever I want. So they've got multiple targets down here that they've brought in and just legitimately made them empty for no other reason other than I want mine to win. So you can put these together however you want. And in theory, you can use MSBuild for things that have absolutely nothing to do with compilation. If you want to, say, concatenate files together. The other thing I didn't touch on is you can actually write your own tasks as well. You aren't necessarily limited to the tasks available here. This can be a little bit problematic and you have to be careful. So when you build a task, you have to be conscious of the fact that MSBuild, what version of the SDK it's built against. Because, for example, I can't use a task targeting net 6.0 in an older MSBuild because it can't load that assembly. So your task has to be built with the version of SDK that MSBuild is using. Oftentimes the workaround for this is just build a .NET Global tool and invoke that from MSBuild. Then you don't care about what version of the SDK MSBuild was built with. You can compile your runtime right into your exe. You'll note my little CSC exe that I built, this guy here, if we dive in, build, release, net6, winx64, publish, you'll note I compiled it down to a single standalone exe. That way, I don't care what version of .NET you have on the box. I don't care what version of MSBuild you're running. Please just execute that exe. Don't think too hard. So oftentimes, that's a much easier approach from doing it. There is one other thing I will mention and then tell people to steer clear of. You can actually inline C# inside of MSBuild directly. I will show this, and then I will close it before anybody throws up. Inline task. Now, where's an actual one that actually shows some C#? If this is your idea of hello world, and you're totally cool with writing C# using XML, you can do that. And then you don't have to necessarily worry about which version of .NET it's being used with. I would discourage this. I have yet to figure out when this is helpful versus just writing my own task or writing my own global tool. This has been around for a while. If you want something quick and dirty, maybe.
To expand the number of functions to 31.
Yeah. So, but again, I don't like writing my C# inside of an XML-based file. That just feels dirty to me. Yeah, that's a good point. Hopefully you don't need an ampersand. There is a list of characters that you do need to escape inside of it. People probably saw in my other one when I was invoking things like quotation marks, because otherwise other Cameron has a space in it, and who's done a lot of CLI work, the spaces are going to be breaks, and well, you got to quote those. So making sure that you do escape things properly. Typically XML escaping, there is a handful of things like specifically the $, at, percent, it's like half a dozen of them where you do have to, if you want those characters literally, you do have to go get the XML entity and drop it in its place. So, what else? Okay, going once, going twice. Okay, with that, I will say thank you for coming. Just as a reminder for people, if you are interested in more of our user groups, please sign up. You'll find them on either the meetup pages or on our socials are the easiest way to track it. And if 5 people want to go hit the follow on YouTube, I get to claim credit. I told the marketing team I was claiming all of the subscriptions they get between now and Friday. So if you're watching this between now and Friday, please click the button. So then I get to claim it. We're at 100? Just! Nicole, we got to 100 YouTube subscribers. You're welcome. I'm taking credit. I don't really know if I did much, but yeah. One of the hey, if I have to hold somebody down and arm wrestle them for it, I mean I'll lose, but if I get the subscription out of it, we'll call it a win. So cool. Thank you everyone for coming. Hopefully we'll see everyone next month in May. Have a good one.